I'm going to ask you to stop the video and have a go at this exercise, which is similar to the one I did before. If the solubility of barium fluoride is 1.1 grams in 1 liter of water at 25 degrees, what will be the solubility product constant for barium fluoride at that temperature? Stop the video now, please. I hope you stopped the video and had a go at the exercise. Again, the first step is to write the equation that describes the dissolution of barium fluoride, in this case in water. So that would be the liberation of the barium 2 ions and the liberation of the fluoride ions, 2 fluoride ions. And the next step will be to write a general expression for KSP of that salt, and would be the concentration of barium 2 ions times the concentration of fluoride anions to the power of 2. And now I need to look at how I can work out the concentration of those 2 ions from the information that the problem is giving me, which is the solubility of barium fluoride in water. And for that, I need to look at what the question is telling me. What the question is telling me is that if I have a certain number of moles of barium fluoride, I will produce the same number of moles of barium 2 plus and twice the number of moles of fluoride ions, because I get the reaction rate is 1 mole of barium fluoride gives me 2 moles of fluoride ions. So if I substitute that in my equation, and I think that in all cases I can use volume 1 liter, so I can use moles and molarity indistinguishable in a indistinguishable way. I would have the concentration of barium 2 ions would be N, and the concentration of fluoride ions would be 2N and to the power of 2, because that's what the formula is telling me. So if I sort this out, if I do the calculations, I end up that is 4N cubed. And now I need to work out what the value of N is. Well, the value of N is, how many moles of barium fluoride dissolving 1 liter of water will I have? Well, that's what the problem is telling me. It's telling me the solubility of barium fluoride in water. It's just not in molarity. It's giving me the information in moles per liter. But that's fine, because I've got the molecular mass of barium fluoride, which is 175.34. So 1.1 grams, and it's already in grams, so I don't have to convert anything, divided by 175.34, which is the molecular mass of barium fluoride. That is, give or take, 6.2, 10 to the minus 3. And that is my value of N. So now if I substitute in my equation, to the power of 3, and that is, give or take, 9.8, 10 to the minus 7. So that is the solubility product constant for barium fluoride at 25 degrees. So is that value correct? Well, we can look at the previous slide and see if the calculations I've done are correct. So if I go here and I look at the solubility at 25 degrees for barium fluoride, or the KSP for barium fluoride, it tells me that it's 1 10 to the minus 6. And that is similar to the value I've obtained, because if you think about it, 9.8 10 to the minus 7 is approximately, if you round up, 10 to the minus 7, which is the same as writing 1 times 10 to the minus 6. So this last part of the exercise you don't have to do in a normal, when you're solving a normal exercise in class or in a workshop, you would stop here The reason why I've done this last step is because I wanted to show you that you can actually check if the values you are getting are correct, because you can find out this information, solubility product constants, at various temperatures, because that's all tabulated data. So you can check if your suggestions, if your calculations are correct in that way. Another little exercise related to solubility product constants. If you look at these three salts from lead 2, lead chromate, lead sulfate, and lead sulfide, and you've got the different three KSP values, one for each salt, which of those three compounds would give the greatest number of lead ions dissolving water, assuming that you're always adding it to the same volume of water so they can be compared? Stop the video now, please. So in this case, I can compare directly these three salts because, well, all the KSP are at the same temperature, and all the salts liberate the same number of lead 2 ions. They all have this structure, Pb and a counter an ion, and when it's dissolving water, they all liberate one ion, lead 2 ion, and they counter an ion, whichever it is. So they can be directly compared by looking at the KSP value. Which one would give me the highest number or the greatest number of lead 2 ions? Well, it would be the one with the largest KSP. So lead sulfate, that is the one that will liberate the greatest number of lead ions. The second would be lead chromate, which has the second greatest KSP value. And finally, the most insoluble one would be lead sulfide, which is the one that has the smallest value for KSP.